So I'd love to go back to dark matter, what we were talking about before. What would you say, is there any experiments that are going on right now in trying to detect dark matter that are, pretty solid?
Do you think it will be the Large Hadron Collider that will happen to come across one of these weak, massive particles?
So, this is a very important topic. So as I said before, dark matter is notorious for being, at this point, able to be a lot of different kinds of particle, or even more than one kind of particle. So we just don't know. So again, here plurality is important. Since there are many possibilities, we need to, for the moment, do a range of experimental explorations and see which one comes up trumps. It could be the Large Hadron Collider, but it may not be. If dark matter is a certain kind of particle, then the LHC may be the best place to find it. But there are plenty of other kinds of dark matter which the LHC would not be able to find. And other experiments need to be designed to do that. And they have been, and they are being done. So there are these things called dark matter direct detection experiments, of which there are several around the world. So these are just detectors. These are instruments which are designed to detect particles. So what they do is just build one of these detectors and instrument it and look at the detector. Put the detector deep down a mine or under a very big mountain. This is in order to shield it from cosmic rays.
Yep.
And then what they look at, so what the detector is designed to be sensitive to recoiling nuclei. So in every atom there's this nucleus right in the center made of protons and neutrons. The idea is that a dark matter particle may come along, collide with a nucleus, and then the nucleus picks up energy. Right?
So you're not trying to detect the actual dark matter particle, but rather what it's doing to the nucleus.
Of course, because the dark matter particle you can only see through its effects. So what you're doing is you're waiting for a nucleus to suddenly pick up kinetic energy for no apparent reason, right? So it's like you have in the room an apple, right? And you do nothing to the apple, and suddenly it flies off the table, right? So you would say something hit that apple, all right? So now imagine that apple is the nucleus inside a detector, and suddenly you see it shoot off. And you keep seeing nuclei shoot off occasionally. You would say, well, something is bombarding that nucleus. It's something that's very weakly interacting, that can get under a huge mountain or down a kilometre or two under the earth in a mine. So you would say this looks awfully lot like dark matter. So that's what direct detection experiments try to do. And there are several around the world. There are even some that claim to have detected dark matter already.
Oh, big claim.
Yeah. So and this has been going on for several years. Controversial. The experiments are not universally believed, or the interpretation of the experiments as the detection of dark matter is not universally believed. And there are experiments that contradict other experiments and so on. It's a confusing but exciting story at the moment. So dark matter is something, is I think one of the most important areas in fundamental physics and indeed in fundamental science at the moment, and is under very active consideration both theoretically and experimentally, and is one to watch. And there could be a breakthrough, it has the potential for a breakthrough, over a reasonable time frame. Yeah.
Do you think the dark matter particles, do you think their nature is of particles similar to ones that we know, or they will have the complete, or that they're rather different than what we know? I know they're non-luminous, so we can't shed a light on them in one sense, but do you think they're completely different to normal matter?
My prejudice is that there isn't just one dark matter particle, but there's a whole set of particles which interact with each other, just like ordinary particles like electrons, protons, and neutrons interact with each other. I think there's another kind of system like that, a set of particles all interacting with each other.
They just don't interact with light,
but they don't
detect them.
Exactly. They interact with ordinary matter gravitationally, because that's how we've detected dark matter, but they certainly don't interact with light, at least certainly not very much. They can interact a little bit, but very, very, very weakly.
Which makes it very hard to detect.
Well, that's right.
They're flying around this room, flying through us at the moment. They just